One last type of quadrilateral to talk about here, and that is a trapezoid. So everything we've talked about before was a parallelogram. This one is not. This one is a quadrilateral, but it is not a parallelogram. And you can see that pretty clearly. These two sides here are clearly not parallel to each other. The special property it does have, though, is that its bases are parallel. Now, I said that, and I actually haven't quite written this out yet, but let's go ahead and call this base 1 and this base 2. And so the way I think of it is its bottom and top are parallel to each other. And if you were to set it on one of these sides, you wouldn't get that nice parallel floor and ceiling. Now, one thing to add to this now is, because that's the definition, is kind of not its version of a diagonal, but this idea of a median. Okay, so what we have to do now is we have to figure out how we can relate the two bases to this median. And the reason we might want to do that is, of course, the middle of things can be pretty useful. And I should mark that down here that the median is the middle. So this piece here is congruent to this piece here. And this piece here is congruent to this piece here. So it's exactly in the middle. It's also parallel. Okay. And there's multiple reasons going on for all of this, but all three lines are parallel to each other. And so we have this nice symmetry going on. And one other thing that I want to add into this is that if we call this angle 1 here and this angle 2, well, we know that angles 1 and 2 are supplementary to each other because they're same side interior angles and our bases are parallel. And that's hopefully going to make this next part make a lot more sense. So what I'm going to do now is I'm actually going to take this piece that's right up here and I'm going to move it right over here. And then I'm actually going to rotate it around until that base is again parallel to the other base. And then I'm going to go ahead and just move it right over here and lay it right on top. And again, those are congruent to each other. And this piece right here is just base 1. And the top part on top here is, of course, just the median. And once again, what we've created here is that relationship where I know that the part on the top has to be the same as the part on the bottom. Okay, because we've now created a parallelogram, in fact. And again, I'm skipping a couple steps on the proof, but basically we've determined now that this length here, which is 2m, or 2 times the median, must be the same as the length on the bottom, which is base 1 plus base 2. Hopefully you can logically follow me, even though I'm skipping a couple of the formal proof steps here. But with that, we can now set up an equation that 2m is equal to base 1 plus base 2. And that I can then just multiply both sides of this by 1/2. You could divide by 2 as well, but I prefer to multiply by 1/2. I think it looks a little nicer. And we wind up with the fact that the median is in fact just 1/2 times B1 plus B2. 1/2 times B1 plus B2, or B1 plus B2 divided by 2. Oh, median, average, middle, this is all the same thing. Really what we're finding here is that the median is just the average of the two bases. Which will make a lot of sense because if you look up the term median, it just means middle, and the middle of any two numbers is just their average or their mean. And again, all these words are kind of starting to come together a little bit. And so that's another property of our trapezoid. And in fact, what we ended up finding as well is the way we got to here is that because of those parallel lines, we're going to be able to use same side interior angles and some of those other properties of parallel lines that we should be pretty darn comfortable with now.